I'm Monvip Chakravarti. We at DXSure have looked at using AI to help with medical diagnosis of certain degenerative conditions. As a use case, we have chosen the spinal cord for reasons I shall mention shortly, and we've created an AI model to identify different adverse conditions. So a little bit about the background. As per World Health Organization, lower back pain is a very concerning issue, likely to affect close to 1 billion people by 2015. It can be experienced by anyone, and most people experience it at least once in their life. Health services, as we could empathize worldwide, continue to struggle due to various factors such as staffing levels to provide the expected patient outcomes. In the NHS England itself, trauma and orthopedics stand out with the largest waiting list exceeding 800,000. Low back pain is a single leading cause of disability worldwide, and the condition for which the greatest number of people may benefit from rehabilitation. We believe we can improve the diagnosis of these conditions, and new technology developments are here to help with that. A little bit about the spine. It consists of 4 regions. The top region is called the cervical region. The middle layer is called the thoracic region. The lower back area is called a lumbar region. And then there is another region called the sacral region, which consists of fused vertebrae, which are nothing but bony structures. And the spinal cord runs behind these bony structures, or vertebrae as they are called. And the nerve endings arise from the spinal cord that you can see in this picture here. And these nerve endings pass through the gap between the vertebrae, and that gap is called a foramen. In a healthy spine, the foramens are pretty clear. So is the spinal canal. And so there is nothing pressing against the nerve endings, and so it's healthy and flexible. When problems affect the spinal cord in terms of outgrowths or something pressing against the nerve endings, that's where people suffer from pain, or it can also lead to disability if untreated. Radiologists refer to use MRI, which is magnetic resonance imaging technique, to identify these conditions, and they classify them from whether it is mild to severe. The blocks may happen for issues as simple as fat deposits, right? And MRI allows the spine to be looked at from different angles, both along the sideway view, which is what you see here, or even from the top-down view, which is called the axial plane. What we have done is taken a load of MRI scans. We've used a foundational neural network based out of EfficientNet to assess these images. Now, because foundational neural networks are quite generic, we have had to train them further to fine-tune them, so add additional layers of within the neural network. What we have been able to identify is whether specific conditions exist or don't exist, for which we have achieved around 95% accuracy, and also the probability whether the issues are normal, moderate, or severe. At this point, I will switch across to give you a quick demo of what we have done so far. So, which is momentarily I'm there. So here what you see, this is a basic tool, demonstration tool. We have lots of patients, and this is one patient who has gone through 4 sets of MRI scans. Now, MRI scans have multiple images, as you can see at the bottom here, like there are 16 images in one of these MRI scans. But this particular one, if we view, you would notice that the model is looking iteratively across these different image frames, and it predicts if there is a problem or there isn't a problem. At some places, it sees from certain angles, it is able to detect a problem, and that's what it highlights. So this is on the top-down view of a foramen. If I change the second patient and maybe go to a different set of MRI scan images, and we see I think this one will be from this side view. So here we're looking at the spine from a side view, and the model is looking through all of these images and it's predicting whether there's a problem or not. So here, for example, it sees from this angle that in the vertebrae, in a set of vertebrae where it thinks it's L3, L4, but it's on L1, L2, but it identifies a problem, which is a right neural foraminal narrowing. So the narrowing of the foramen, basically. We believe this will be, and it does it pretty accurately. It identifies that the severity, as you can see, the actual severity is normal to mild. It also identifies it as normal to mild here with 80% probability. So this is an initial work in progress. We will continue to improve the model. This is meant to kind of showcase what we have done so far, and we invite opinions, views from our colleagues in the medical fraternity. If you see this of use, please let us know. You can reach me at mondweep@dxsure.uk. We are continuing to improve our models and find a way of making it available for use. Thank you very much. Bye-bye.